So the first thing we're going to talk about is factoring trinomials. If you have b squared plus 8b plus 7. Now, before we get into this, I really want to make sure that you understand what factors are, okay? Factors are, and I hate to use the word things because it's such an elementary word, but I'm going to use it anyway, okay? Are things, numbers, monomials, whatever, that are multiplied. Terms are added or subtracted. Okay, and I put or subtracted in parentheses because technically speaking, terms are added. Subtraction is defined as adding the opposite. So I always say that because I don't want anybody to think, it's not if it's got a minus sign in front of it. So what you're looking at here are 3 terms. This is a trinomial, okay? 3 terms that are being added or subtracted. I am asking you to factor it, which means I'm asking you to write it as a product, as something times something, okay? You learned you are supposed to have these skills where you are looking for things that multiply to be 7 but add to be 8, right? I organize my work in an X, a big X. It is a graphic organizer, if you will. It is not a variable, okay? It's just a way, it's like a chart. Some students do factor sum charts where they do little T-charts and they have factors and sums. Whatever you do is fine. You do what you do, okay? I do this method. So if you want to watch and see, you may like this method. You probably learned this method because that's where I first learned it when I taught there, okay? So I'm looking for things that multiply to be 7 but add to be 8. These are pretty easy. 7 and 1. Then you come over here and you set up your 2 binomials because a trinomial will factor into a binomial times a binomial. And since it's b is your variable, you're going to put b and b because b times b makes b squared. And then these numbers are the ones that go into your factors. So it's a positive 7, you write plus 7. It's a positive 1, you write plus 1. It does not matter if you have b plus 1 over here and b plus 11 over here. Either is fine, okay? When you get into some with negatives, you have to be a little more careful. So let's factor this trinomial. N squared minus 10n plus 9. Again, I set up my little graphic organizer here. And I like to put my little signs in there, which one I want to do what. So I want it to multiply to be 9 and add to be not 10, but negative 10, because that 10 has a negative in front of it. My 2 numbers are going to go there. They're going to go into my binomial factors. And they would be, now look, you have to think. 2 numbers are going to multiply to be a positive, but add to be a negative. They must both have to be what? Negative. So it's going to be negative 9 and negative 1. When I add them, negative 9 plus negative 1 makes negative 10. Negative 9 times negative 1 makes positive 9. Okay? So it's going to be n minus 9 and n minus 1. So these are factoring trinomials where the coefficient on the squared term is 1. Okay? These I call easy X. And I call them easy X because the coefficient is 1. The coefficient, and I'll probably spell that wrong, but maybe not, of the squared term is 1. Okay? Let's do another one. Okay. 4v squared minus 4v minus 8. Now I kind of jumped the gun jumping into trinomials, and I really should have mentioned greatest common factor first. So this one kind of leads me to back up into that. You should always look to see if there's a common factor in all of the terms before you try to do any of the factoring techniques that you know, okay? If there's a common factor, then you should factor that out first. There is a common factor in this one. It's 4, so you're going to pull the 4 out front, write what's left. In other words, you're going to divide 4 into each one of those. The act of factoring is division. Factors are things that are multiplied, if that makes sense. So when I say factor something, you're really dividing it into 2 factors, okay? Pull the 4 out. You're going to divide 4 into each one of those. You're going to get v squared minus v minus 2. Now this looks like an easy x problem because the coefficient that's on the v squared term is 1. So I simply am looking for things that multiply to be negative 2 but add to be negative 1. What are those 2 factors? Positive 2 and negative 1, or negative 2 and positive 1? Negative 2, positive 1, right? Because, let's add them and see. I know they multiply to be negative 2. Negative 2 plus 1 is negative 1. If you did it the other way, you would have got a positive 1, wouldn't you? So these are your 2 numbers that go into your factors. The 4 just hangs out front. He does have to be there. You can't lose him. Okay, he is part of this trinomial factorization. So it's v, and it's minus 2 plus 1. How can you check these problems? Multiply it. What's the method that we use for multiplying binomials? FOIL. So you could check it by foiling it. What you're doing is you are unfoiling it. Okay, you're taking something that's been foiled, that process has been done to it, and you're undoing it. Okay, you're writing it as 2 factors being multiplied. So if you foiled this, you'd get b squared plus 1b plus 7b plus 7. The outer and the inner terms usually add together. They do in this case. That's where the 8b comes from. Okay? That is how it's just a review of factoring the trinomials that are easy to factor. Division. This will be online for you too. I'm going to post a video for you. Okay? Now, before we go into those, let's look at, no, we'll go on into those. That'll be okay. All right, so now we're going to talk about trinomials that I call the technique hard X. Okay? Just to make it really simple. Easy to remember. You got easy x, you got hard x. This is easy because the coefficient of the squared term is 1. So now what we're going to do is we're going to look at coefficients on the squared term that are bigger than 1. Okay? Start with this one. I'm going to change colors here. So 3p squared minus 2p minus 5. This is called a hard X problem, or that's my technique. Let me say that. I call this method hard X because the coefficient, I'm going to abbreviate that, coefficient of the squared term is not 1. It's bigger than 1, okay? So it's a number, is greater than 1. And I hate to say greater than because I could put a negative number on there. So I guess we should just say not equal to 1. That's probably best. Okay? Okay, so you have a number on your squared term. In this case, I have a 3 on my squared term. So what's going to happen is, in these factors here, that's going to mean that the first times the first, when you do first times first, is going to have to give you 3p squared, not just p squared. So you have to decide, you know, what are the numbers going to be that are going to go in those factors. Now, a lot of you have learned trial and error. Who has learned trial and error? Anybody know? Okay, that's where you just sit and you just put in factors of 3p squared and factors of 5, and you play with the signs and you just figure out which one multiplies to be that. That is fantastic. If you know that, you get it, and that's good, because you understand the process behind it. But I have a technique that's a little bit quicker. I'm glad it's getting recorded this time. And it works every time. Some students catch on to it really quick, some don't. If you don't like it, you keep on doing what you do, okay? What I do previously, let's go back up here for just a second. This trinomial is in the form x squared plus bx plus c. And so the number that goes here is the c, and the number that goes here is the b. Okay? So you look for things that multiply to be c, but add to be b. Okay, that's what we were doing. Multiply to be the last, add to be the middle. These are just variables representing the coefficients there. Okay, if I'm going to scroll down, this will be online, I promise. Okay, hard X problems are when there's a number here other than 1. Okay, so it's in the form ax squared plus bx plus c. So there's a new coefficient that's been introduced here. To do this, you have to take responsibility for factoring that a appropriately, okay? So the way that we do that is, instead of it just being things that multiply to be c that go here, it's things that multiply to be whatever the product of a times c is. You still want it to add to be the middle term, b. Okay? At which point you're going to get a couple of numbers here. Okay, you're going to get 2 numbers, not hashtags, 2 numbers. And those 2 numbers are going to go into your factors. So I'm going to show you this abstractly first, and then I'm going to come over here and do it with the numbers, okay? So these 2 numbers are going to go into your factors. The first step that I write is not correct. It's like scratch work, if you will, okay? I write x and x. Now, we all know that x times x is not going to make ax squared. I'm going to have a number in front of one of those, or maybe both of those, okay? But this is my scratch work. So x and x, and then plus or minus, whatever it is. I'm going to put a plus right now. And then you take those 2 factors that you got right here, and you put them over a. Because you had to multiply the c by the a to find those 2 numbers. So when you bring that over here, you're going to need to divide those 2 numbers by the a to kind of make it equal out. At this point, you will reduce the fractions, if they can be reduced. And then you will bottoms up. You will bring the bottom number, if there is still a bottom number, up in front of the x after you reduce the fraction. That's how I do it. Again, if you already have your way and you get these right every time, don't let me mess you up. Okay? You do what you know to do. I cannot stress that enough. So let's look at this problem. We're going to use this hard X technique. because it's pretty cool. Even if you don't like it, it's pretty cool to see. So the first thing I'm going to do is I'm going to multiply. I realize that I have an a on my squared term. It's not an x, it's p, but it doesn't matter. And I'm going to multiply 3 times negative 5. Now, I am really big about writing what I'm doing because I don't want anybody to be lost. And I don't like to assume that you know, okay? So 3 times negative 5 is negative 15. So I'm going to be looking for things that multiply to be negative 15 and add to be the middle term, which is negative 2. Those two numbers are negative 5 and positive 3. Is that correct? Okay. Negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. Then I'm going to come over here, and remember now, my first step is not mathematically sound. I have some very good friends who have been taught for 30-something years. They do not like this. This is not mathematically sound. This first step is incorrect. It does not equal what's above it. Blah, 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 blah. Okay, I get it, but it works. And some kids just need something that helps them, okay? They just need something that makes it click. So this is the saving grace for a lot of the students that have learned it. All right, so here we go. You're going to put P and P. Again, that's not right. And it's going to be minus 5 over 3 and plus, because 3 is positive, 3 over 3. Where did these 3's in the denominator come from? They are the what? The A, the coefficient of the squared term. Now your step is to reduce if possible and then bottoms up. 5 over 3 will not reduce. So you're going to bring the bottom number up and you're going to get 3p minus 5 as your first binomial factor. 3 over 3 will reduce to 1, so there is nothing to bottoms up there. And you have factored it. FOIL it to check it. It works every time as long as you are really careful with your signs, okay? You just have to be very careful with your signs and with all your process. Did y'all end 098 with factoring? Was that the last thing you did? So it's fresh, isn't it? Okay. Did you learn this way? Okay. I found a piece of paper in one of the other rooms a year or two ago, and it had this on it, but it was actually opposite. But it still worked. It was just the same thing, but it was just a little opposite, so it was kind of different. They did their bottoms up here. I think they did tops down or something. I don't even know, but it was funny how it was completely opposite, but it worked. So, all right, we're going to do one more of those, and then we're going to move on to a couple of other reminders about factoring. How about I let you try this one? I'm just going to leave this displayed for you and see if you can factor that one. You can do your technique or mine, whatever you want to do. Just see if you can get it right. All right, let's go ahead and try to work it. If you're not finished, that's okay. All right, so we are going to multiply A times C, so 4 times 4, to get the number that we're looking for factors of. So that's 16. So we're going to look for things that multiply to be 16 and add to be negative 17. So those two numbers would have to be negative 16 and negative 1. Negative 16 times negative 1 is positive 16. Negative 16 plus negative 1 is negative 17. So I'm going to come over here. Remember, your first step is not correct. It's just scratch work, n and n. Okay, because n times n does not make 4n squared. That's the whole argument. Okay, but I'm going to do minus, because it's negative, 16 over whatever the a is, which is 4, and then minus 1 over whatever the a is, which is 4. You're going to reduce the fraction. If it will reduce, this reduces. 16 over 4 reduces to 4. This one does not reduce, so you bottoms up. You bring the bottom number up and you put it in front of the n. 4n minus 1. And that works. If you FOIL it out, it does work. Okay? All right, so we're going to move on and look at factoring, a couple of other special types of things. I want to talk about factoring a difference of squares first. Now, a difference of squares has two terms in it. And when you look at your factoring flow chart online that's on Blackboard, it's divided into, does your polynomial have 2 terms, does it have 3 terms, or does it have 4 or more terms? And that's how you decide which technique you want to go with, okay? So if it has 3 terms, you know it's going to be an easy X or a hard X problem. If it has 2 terms, there's a couple different things it could be. You should always look for a GCF first, and then you check to see if it's a difference of squares, okay? A difference of squares is a perfect square number minus another perfect square number. 16n squared minus 9. A difference of squares always factors the same way. And if you can remember it, it will save you tons of agony. Always factors the same way, every time. It factors into the sum and the difference of the square roots. Every time. 1 plus, 1 minus, doesn't matter which one you put first, and the square roots of the two numbers there. So what's the square root of 16n squared? 4n. What's the square root of 9? 3. So it's going to factor into 4n plus 3 and 4n minus 3. You can check this by FOILing it out. And I'm going to check this one because I want to show you what happens. The first times the first is 4n times 4n. That's 16n squared. The outer is 4n times negative 3. So that's negative 12n. The inner terms are positive 3 times positive 4n. So that's positive 12n. And the last terms are positive 3 times negative 3, which is negative 9. If you will notice, the outer and the inner products always add to be 0 on a difference of squares. Okay? So I had a student back probably my first year of teaching who said, oh, so we just FLA. We just FL. FLA, right? And so if you were multiplying, when we were learning to multiply, okay, then he realized that if it was a sum and difference, he just needed to do the first and last, and he would be fine. And that's the case as well, okay? So you can think about it because the O and the I always cancel or add to be 0, however you want to say it, in a difference of squares. So 16n squared minus 9 factors into 4n plus 3 and 4n minus 3. So if I gave you n squared minus 25, how does it factor? Very good. And you're finished. Okay? Now, some of these, as you get into your higher mathematics courses, raise your hand if you have to take another math class after this one. Okay, left side of the room. Then as you get into that, you're going to be dealing with some that could factor repeatedly. This one does not, but it happens a lot of times when you have a fourth power on the variable. Okay, a to the fourth is a perfect square. The square root of it is a squared. So it would be a squared plus 3 and a squared minus 3. See if I can find one that does factor repeatedly to show you. I can't find one on this particular sheet. I don't think you're going to have any to do like that, but if you do, it'll just be something that's going to go more than once. If I could think of one. Let's do this one. This one does what I want it to do. 16x to the fourth minus 81. That is a difference of two squares. The square root of 16x to the fourth is 4x squared. The square root of 81 is 9. So it'll be 4x squared plus 9 and 4x squared minus 9. What happens is that one of these factors is also a difference of squares. You see? So you have to keep, it's called a repeated factorization. You just have to go a little bit further with it and factor it as well. How do you know? You don't. You have to take note. You got to pay attention and think, okay? So this factors into 2x plus 3 and 2x minus 3. When they ask you to factor, they want it in its completely factored form. Completely factored form. Okay? Any questions? Okay. We are going to go into a factoring by grouping problem. Did you guys factor things that had 4 terms in them? You had a group, first 2, last 2, that sort of thing? Y'all remember that? Okay, good. Factor by grouping is going to be the next review topic. This is when you have 4 or more terms. Again, that factoring flow chart that's posted on Blackboard, you can print it off. It has all this information on it in a more detailed form, okay? All right, so to factor by grouping, you are going to take a polynomial. Usually the ones that you'll have in this class, I would say all the time in this class, are going to just have 4 terms in it. You got a 4-term polynomial. You cannot factor it with any of the techniques that you've learned so far. So what you have to do is you have to group the first 2 and the last 2 together. Now, if there is a plus sign on the 3rd term, you will group the plus sign outside. But if there is a minus sign right here, you're going to have to group it inside. And then we're going to factor it out. So it gets a little confusing if there's a minus sign right there. I'll do one of those in a minute. All right, we've got our first group here and our second group. Your job is to factor out the greatest common factor in the first group. So what's the greatest common factor of these two? 8r squared. And you would be left with r minus 8. And then there is no factor to factor out of this. So what you want to do is you want to put a 1 in front of it. Because there's a 1 everywhere. We've learned that, right? 1 is always there. Okay? 1 is always times anything. You can assume that, correct? So put a 1 in front of it. Then you should notice, let's do this, that this term has a common factor, these 2 terms have a common factor of r minus 8. Y'all, this is one term and this is 1 term because there's the plus sign that's separating those 2 terms. So now you think about it as what's the GCF of these 2 terms? Well, they both have an r minus 8 in common. So you're going to pull the r minus 8 off to the front. You can put it in the back if you want to. I always put mine in the front. And then you're going to write what's left. 8r squared plus 1 is what goes into this parentheses. If you FOIL this out, you are going to get that 4-term polynomial that you started with. You have a question? Okay, let's do one more, and let's do one that has a minus sign on the 3rd term, and then we'll get into our text tonight. All right, here we go. We're going to factor this. 4v to the 3rd minus 12v to the 2nd minus 5v plus 15. We're going to group our first two and our last two. There is a minus sign on this term. I want you to group it inside the parentheses and just stick a little plus sign in there so you remember that those are not multiplied times each other. That sign is the sign of the 5, right? What is the GCF of these two terms? The first two. 4v squared, good. And you're left with v minus 3, very good. Now here, because this is leading with a negative, you're going to factor the negative out, but you're going to pull it off of both of them. If you had grouped it outside, you would have only pulled it off the 5 and not pulled it off the 15, and you really would have changed the problem. Okay? So that's why we have to group it inside to start with. So I'm going to factor out a negative 5. So you write minus 5. And then what's left is v minus 3. Now here's the clue to this, is that this one should be the same as this one. If it's not, you've probably messed up somewhere. You need to check your work. They have a v minus 3 in common, so I'm going to pull it out front, and I'm going to be left with 4v squared minus 5. I just told my sophomores today, factoring is forever. It does not go away. So as long as you are taking math classes, you will have to be able to factor from this point on, okay? All right, that's all we're going to review on factoring. We are going to pause